Every AI tool you use right now is about to hit a massive infrastructure wall, and nobody's talking about what happens when data centers can't keep up. Look, we're in the middle of the biggest AI boom in history. ChatGPT, Claude, Gemini, they're all getting smarter, faster, more capable. But here's what's actually happening behind the scenes. The companies building these tools are in a silent race to build enough computing power just to keep the lights on. And the numbers are wild. Data center capacity is projected to roughly double by 2026. We're talking about billions of dollars being poured into new facilities, new power infrastructure, new cooling systems, all just to handle the compute demand that AI is creating. Microsoft, Google, OpenAI, Meta, they're all expanding at speeds we've never seen before. And if you care about AI at all, this matters way more than you think. So let me break down what's actually happening, why it's happening, and what it means for you and the tools you use every day. First, the scale. Right now, a single large language model like GPT-4 or Claude runs on thousands of specialized processors, mostly NVIDIA GPUs, all connected together in massive clusters. Training a cutting-edge model takes weeks and costs hundreds of millions of dollars in electricity alone. But here's the thing, that's just training. Once a model is trained, you've got inference. That's every single time someone like you or me uses ChatGPT or Claude to ask a question. Every prompt you type spins up compute. Every response streams back through a GPU. Now multiply that by hundreds of millions of users, billions of queries per day, and you start to see why data centers are becoming the new oil fields of tech. The amount of compute needed isn't growing linearly. It's accelerating. More users, more models, more use cases, more AI-powered features baked into products you already use. Your email is getting AI summaries. Your phone is running on-device AI. Your search results are being ranked by AI. Every layer of software now wants to be smarter, and smarter means more compute. So the infrastructure had to respond. And it is. We're seeing a shift in how companies think about data centers. It's not just about building bigger facilities anymore. It's about building smarter ones. More efficient cooling. Some facilities are now using liquid cooling instead of air, which is a huge deal because electricity cost is dominated by keeping the equipment from melting. Better power distribution. Modular designs that can scale up or down. Some companies are even building data centers closer to the equator where it's easier to cool things down naturally. But here's the catch. Even with all this innovation, there's a hard constraint. Power. You can't just build infinite data centers everywhere because the electrical grid has limits. You need reliable power, and a lot of it. A single large data center can draw as much electricity as a mid-sized city. That's not an exaggeration. So companies are making strategic bets on where to build. Some are investing in nuclear power. Others are buying land near hydroelectric dams. Microsoft just made a deal to buy power from small modular reactors. This is how serious it's gotten. Now, what does this mean for you? There are a few layers here. First, pricing. Right now, the big AI companies are burning money on compute like it's going out of style. They're offering cheap access to AI tools, or free access, because the market is still consolidating and they're fighting for users. But that math doesn't work forever. As data center costs rise and the novelty of cheap AI wears off, you're going to see pricing shift. Some services will get more expensive. Others will get better at optimizing compute so they can stay cheap. The companies that figure out how to run AI efficiently are going to win. The ones that don't will have to raise prices or shut down. Second, capability. More data centers means more compute available, which means bigger models, longer context windows, faster responses. The tools you're using in 2026 will be noticeably smarter than what we have now, partly because there will be more computing power to throw at the problem. But it also means more specialized AI tools for specific tasks, because the barrier to entry is dropping. Right now, only the biggest companies can afford to train and run massive models. As infrastructure gets commoditized, smaller companies and researchers will be able to build AI too. Third, geopolitics. This is the part people don't talk about enough. Data centers need to be built somewhere, and the countries that can support them, that have stable power, good real estate, skilled labor, are becoming strategic assets. The US is trying to keep AI leadership by securing chip supply and power. China is investing heavily in their own data center infrastructure. The EU is trying to build independent capacity. This isn't just business anymore. It's a race for technological sovereignty. Fourth, environmental impact. Yeah, AI is going to use a lot of power. A lot. Some estimates suggest that by 2030, data centers will account for a meaningful chunk of global electricity use. That's not inherently bad. It depends on where that power comes from. If it's renewable, great. If it's coal, not great. The companies building these facilities know this is a problem, which is why they're investing in nuclear and renewable energy. But it's something to keep an eye on. And finally, resilience. More data centers spread across more locations means AI services become more resilient. If one facility goes down, others can pick up the load. But it also means more points of failure, more security risks, more things that can go wrong. The infrastructure that powers AI is becoming critical infrastructure, like power grids and water systems. That means governments are going to start regulating it more closely. So here's the thing. The doubling of data center capacity by 2026 isn't just a technical footnote. It's the foundation that everything else in AI depends on. The models, the speed, the cost, the availability, all of it flows from whether there's enough compute to support it. And right now, the industry is in a full sprint to build it. The question is whether they'll build enough, fast enough, efficiently enough, and sustainably enough. Because if they don't, you're going to feel it. Slower responses, higher prices, or worse, rationing. Imagine if AI tools started turning people away during peak hours because there wasn't enough compute to go around. That's not crazy. It's a real scenario if the infrastructure doesn't keep up. But if they do build fast enough, we're going to see an explosion of new AI capabilities, new tools, new possibilities that we can't even imagine yet. The constraint lifts and innovation accelerates. So here's what I'd watch. Keep an eye on announcements from the big tech companies about data center investments. When Google says they're building a new facility, that's a signal about where they think the demand is going. When Microsoft signs a power deal, that's a signal about their confidence in growth. These aren't exciting headlines, but they're the actual story of how AI is being built and deployed. And if you want to actually understand what's happening under the hood with AI, not just the hype cycle, but the real infrastructure, the real constraints, the real story, subscribe. I break down these kinds of things every few days, the stuff that actually matters but nobody's talking about. Thanks for watching.